How are you? Okay, I welcome you to Eko Learners Support for WAEC and NECO candidates. As usual, I am your instructor, Jimo Rashid. If you're ready, let's go.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Today's topic is going to be a very interesting one. Not only that it is interesting, it is fundamental. This topic explains or shed light on so many other things that you are going to learn in chemistry. You're wondering what topic I'm talking about. Introduction to the periodic table. Yes, the periodic table. Just that table contains a whole lot of information which you are going to find out shortly. You're a student of mathematics, I believe, so there are so many other tables. For example, in mathematics, we have the four-figure table, which is a table of numbers. In chemistry, we have a magical table that contains elements. I want you to write the topic in your notes and the dates as we proceed. We've set these three objectives for ourselves. At the end of this lesson, you should be able to understand the structure and organization of the periodic table. Next, you should be able to identify groups and periods and explain their significance. Lastly, you should be able to apply the knowledge acquired from this class to solve relevant questions. Before we go on, let's look at some keywords that you are going to need to be able to understand this topic. The first is periodic. When we use the word periodic, it means something that happens at regular interval. Group, of course, that has to do with a set, a family. Period, something that is also moving to and fro. For example, in physics, we talk about period, which is the time it takes for one complete oscillation. And lastly, electron configuration, which is the arrangement of electrons into their shells. Let's look at the icebreaker activity, which I refer to as the element hunt. I want you to find at least 3 elements in your room or your kitchen and guess what positions these elements occupy on the periodic table. I'm giving you a few minutes to do that. Once you have come across these elements, I'm also asking you, how do these elements differ in their properties? So pause the video now and go ahead and do the adventurous hunt. So welcome back. What did you find in your room? I hope you didn't make a whole lot of mess around the house. What are some elements that are available in your home? Did I hear you say you found a gold ring? Yes, that is an element. You're right, it's an element. In the kitchen, you also found a cooking pot made up of aluminum. That's another element. Can you now see that elements are all around you? Wonderful job you have done. So, what is the answer to the second question? How do these elements differ? Oh, you also said now that there is air in your room. That air contains oxygen, which you breathe in. That is a gas. The aluminum pot, that is a metal. So, these are some of the ways that elements differ. I hope you're itching to find out what more do we have in stock. Let's look at this inspirational quote given by the renowned physicist and an American author. His name is Michio Kaku, and he said, "Chemistry is the melodies you can play on vibrating strings of atoms." I hope you are willing to play those melodious strings. This is the outlook of what we are going to cover in this lesson. We look at introduction to periodic table, a brief history of the periodic table, groups and periods. Of course, model practice question, and we look at the top 5 exam-styled questions. Let's introduce the topic. Since the periodic table contains elements, so the first thing we need to know is what are elements. That's elementary, I know, but it is important to you understanding this topic. An element is a substance that cannot be broken down by any chemical reaction. We have over 100 elements that have been discovered so far, and these are what the periodic table contains. The periodic table itself is a table that shows arrangement of elements in order of increasing atomic number. And you can see we have so many elements: hydrogen in water, oxygen in water. Do you even notice that those elements are contained in the water you drink? Aluminium pots, which you found out in your element hunts. And of course, the gold ring. Let's forge ahead. So, define what element is. But element contains smaller particles. If you look at the structure of an atom of an element, it contains the protons and the neutrons, which are in the nucleus of an atom, as well as the electrons that revolve around the shell. So, we use some numbers to describe elements in chemistry. One of those numbers is what we call the atomic number. Can you say that again? Atomic number. The atomic number is simply the number of protons in an atom. It tells us how many protons are there in an atom. The other number that is used to describe an element is called the mass number. As the name suggests, that number illustrates or represents the mass of an atom, and that is why it is the sum of the number of protons and neutrons in an atom. If you look at an atom of carbon, for example, all of these are used in describing. They are like information, okay, telling you more about the carbon element. The atomic number is usually written down the symbol of an element. So, for example, in the exam, if you have carbon, the number that is written down there is the atomic number. Why? The one that is written up, the symbol of an element, is the mass number. It is very important for you to take note of this information. Let's move on. Now, let's look at a brief history of the periodic table. The periodic table that you have in your hands didn't come in a day. It went through a whole lot of evolution. And you can see the timeline stated right here. In 1989, Antoine Lavoisier was the first to attempt to classify elements into metals and non-metals. Later, in 1829, Johann Wolfgang Dobereiner also did classified elements into what we call triads. That means he grouped 3 elements together and he found similarities among them. In 1864, John Newlands also attempted to classify elements. In fact, he did classified elements and came up with what we call the law of octaves. He grouped 8 elements together and found that they have recurring pattern or properties among them. But the father of them all, the man that we refer to as the father of the modern periodic table, is Dmitry Mendeleev. Dmitry Mendeleev did some magical discovery with the periodic table. 2 things that he did that were profound. 1, as at the time that Dmitry was classifying his elements into the periodic table, some elements have not been discovered. Did you know what Dmitry did? He left space for these yet undiscovered elements. And years later, when those elements were discovered, not only did they fit into the positions that he predicted, they also have the properties he predicted for them. And this is why he is referred to today as the father of the modern periodic table. So, this is the table that we are all talking about. That's what it looks like. But if you look at that table, it contains a whole lot of information. There are elements that are arranged into what we call vertical columns and horizontal rows. We are going to dwell more about the structure of the periodic table as we go on. Now, how are the elements arranged? As you can see here, the green line represents groups. So you have from group 1 down to group 18. Another way to classify the group is actually to ignore the block in the middle. If you look at the periodic table, there are different blocks on it. Now, the first 2 blocks are referred to as the S blocks. This is the block that contains the main metals. While the last 6 blocks are referred to as the P block. What did I say? The P block. Now, between the S block and the P block, we have another unique block that is called the D block. Did I mention to you that the P block actually contains some metals like aluminium, but more importantly, it contains metalloids, which are elements that have properties between metals and those of non-metals. And to the far right, you have the non-metals. You can see the likes of nitrogen, oxygen, and fluorine. Now, the D block contains the group of elements we refer to as transition metals. As the name suggests, they are all metals. The last block on the periodic table is what is called the F block. The F block contains a group that is called the lanthanides and the actinides. The lanthanides and the actinides. So, this is how the periodic table is structured. Let's go on. Now, let's find out how do you identify the groups and periods on the periodic table. Now, sure, you have a family. That's a group. Many of the members of your family share similarities, either by the name you bear or by physical resemblance. That's exactly what happened in the group of a periodic table. Then the periods, like we said, are the vertical rows, the horizontal rows, I beg your pardon. Okay? So let's look more into these 2, the groups and the period. So the group is actually the number, okay? I'm using egg, for example, here to represent the information. The number of eggs in the last pot. So if, for example, you have series of pots, and each pot has capacity that it can hold. Like you have pot 1, you have pot 2, you have pot 3. Okay, arranged like that. I remember that my mom used to have these kinds of plates arranged in the house. So the first port is called the K. Sorry, that is the K shell. Now we are talking about shells now. Okay, and the maximum number of electrons it can contain is 2. Next is the L shell, which can contain 8 electrons. Okay, then the M shell can also contain 8 electrons. Now, the group is actually the number of electrons on the last shell. Let me give you an example. Suppose we have sodium with atomic number 11. If we share the electrons of sodium, mind you, this is not 9, that is A. Okay, if we share the electrons of sodium, the first shell will contain 8 because that's the maximum it can hold. The second will contain, the first will contain 2, the second will contain 8, and of course the third will contain 1. Now, the number of electrons on that last shell, what we call the outermost shell, that represents the group. So in this case, sodium belongs to group 1. Why? Because it has 1 valence electron. Now, how then do we figure out periods? Periods is actually the number of shells that we are able to fill the electrons into. Let's just stick to sodium to explain this. Now, if you look at the distribution of electrons of sodium, we're able to place electrons into the first shell, the second shell, the third shell. So in total, we are able to fill up 3 shells. And that means it belongs to period 3. So the period is actually the number of shells that we put electrons into, while the group is the number of electrons that we have on the last shell. I hope that by now you should be able to identify the groups and periods that a given element belong. So let's move on. Now, elements on the periodic table are of different states. We have those that are solid, like most of the metals, apart from mercury, which is the only metal that is liquid at room temperature. Some of them are liquid, okay, like the bromine, for example, is liquid. Some are gases like oxygen and nitrogen. So you should be able to classify the elements on the periodic table according to their states into solid, liquid, and gas. I want you to pause this video right now and give me 3 elements in these respective categories. Elements that are solid, elements that are liquid, and those that are gas. Okay, so chemical properties. Now, when element belongs to the same group, they have the same chemical properties. If you look at group 1, where we have the likes of lithium, sodium, potassium, rubidium, calcium, and francium. If you share, for example, the electrons of lithium, you will see that lithium has 3 electrons. When you share that, that is 2, 1. If you do the same for sodium with atomic number 11, that will give you 2, 8, 1. If you do the same for potassium 19, that will give 2, 8, 8, 1. You can see that that one is common to all the elements, and that is why they show similar properties. They undergo similar reactions. That is very important for you to note. Okay? Physical property is, of course, those properties like boiling point, like melting point, those are referred to as physical properties. So there are trends or changes as we go on the periodic table based on the physical and chemical properties. Now, this is classifying elements into metals, non-metals, and metalloids. So I believe by now, the task I gave you earlier, you should be able to take care of this. And you can see examples of element that is solid there. The iron rods that is used in construction industry. You have silicon, which is a magic element that has revolutionized the electronic world. All of the smart devices make use of silicon because of its mild electrical conductivity. Oxygen, which is essential for life. Okay, now these are some properties of metals and non-metals. Metals are usually lustrous, means that they give shiny appearance when they are polished. Of course, you saw your mother's gold ring earlier on. Okay, that's a metal. They are malleable, means that they can be beaten into thin sheets. Okay, and they are good conductors of electricity. That's why we have, for example, copper used in cables. Now, let's look at the practice question. Now, the following table gives the atomic numbers of elements V, W, X, Y, and Z. Now, my dear student, I need to let you know that this is the kind of question you are going to come across in your examination. The first and the most important point is that you must not identify these elements. The examiners have given you the element as V, W, X, Y, Z, and that's how you must refer to them throughout your attempt to answer this question. Unless, of course, there's part of the question that says identify this particular element. So once you are given the atomic number, you can see V is 11, W is 16, X is 18, and it goes like that. So the first thing you must do is that you have to share the electrons, because that will let you to know what exactly is happening in the shells. So atomic number for V is 11, so we are just going to share that. That gives us 281. That for W is what? 28. Yes, you are right. 286. Okay? For X, that will be what? 2, 8. This is already 10. And what? 8. For Y, that will be 2, 8. Did you say 9? No. Because apart from the first shell, other shells can contain maximum of 8 electrons. So that will be 8 and then 1. Now, we will not be able to use this notation to write the electron configuration of Z, because that falls among the transition metals. You can see the atomic number is 24. It has gone beyond the first 20 elements. But what we know for sure is that the last noble gas for this element is argon with atomic number 18. And the next configuration is going to be 3D. Okay, that will be what? 3D6. Never mind that. You're going to learn more about how to do that when you learn about the transition metals. So this is what we are going to use in order to answer the question. So let's look at the question that I asked. Which of the elements belongs to group 1? So let's go back. Which of them belongs to group 1? Yes. Can you attempt that? Fabulous. You are right. V, because the number of valence electron is 1 in it, as well as what? Y. Can you see why it is important for you to learn how to write electron configuration? Because once you do that, the answer becomes very clear. So let's go and answer that particular question. That is V and Y. So I'm just going to write there V and Y. You are not explaining anything. That's it. That's what the examiner is asking you to do. Let's look at the second one. Is or are noble gas? Let's go back and see which one is a noble gas. How do you identify noble gas? They are the ones that have completely filled configuration. It means that the valence electron is filled up. It is either 2, which gives duplet, or 8, which gives octet configuration. This is 1, this is 6, and that is our guy there, element X. So we go back and answer this by saying X. That's all. Forms colored compounds. Yes, this is one of the characteristics of transition metals, which I said you're going to learn when you get to that part. So let's look at which of those elements is a transition metal. And of course, that is Z, that belongs to the D block. So our answer there is Z. Yes, element Z. Which one forms an anion? What is an anion? An anion is a negatively charged ion. Yes, the opposite is a cation, which is a positively charged ion. So let's see which one is going to form an anion. Now, if you look at V, V is a metal, so it's going to lose 1 electron. W, yes, is a non-metal. Why? Because it cannot lose 6 electrons. Instead, it has to gain 2 more, and that makes it what? A non-metal. Look at others. They do not fulfill that, that condition. Okay? So, the element that is going to form an anion is what? Is W, because it needs to gain 2 more electrons. So, let's go and answer that. W. Which one will form? Just write it there. W. All right. So let's get to look at the number 5 question, Roman figure 5 question. The question is, which one reacts with water to liberate hydrogen? Now, this is one of the reactions of the main group element. I'm talking about the alkali metals, where you have sodium, potassium. They are so reactive that when you drop them in water, they liberate hydrogen gas. You might want to quickly look at that reaction, but we are going to learn more about that in subsequent classes. Okay, that will give sodium hydroxide and liberating hydrogen gas. This reaction is simply a displacement reaction because the sodium is more electropositive and so is displacing the hydrogen and then liberating the hydrogen as a gas. Okay, so let's look at which of the options corresponds to this. Okay, V there is an alkali metal as well as Y. So our answer to that is going to be V and Y. So I have to clean that so that you can see clearly. That is, the answer there is V. V and Y. Yes, that's the answer for Roman figure 5. For Roman figure 6, which one reacts with water to form alkali solution? If you actually paid attention to the reaction, the equation that I wrote earlier, you will see that apart from the hydrogen that was evolved in the reaction, an alkaline solution was formed, which was the sodium hydroxide. So the same answer still goes here, which is the V and Y. Now, I hope that this lesson has actually helped you to understand better that table that you are holding in your hand. In this lesson, we looked at a brief history of the periodic table. We looked at how to identify the groups and periods on the periodic table, and of course, that knowledge was applied to real exam questions. I thank you for your patience to watch this video to the end.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
If you have any feedback, suggestion, contribution, do not hesitate to leave them in the link displayed right now. I hope to see you next class. Keep learning. Ìtẹ̀síwájú Èkó, àjùmọ̀ṣe gbogbo wa ni. Bye for now.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.